in Elixir, we have the Nerves project. And the Nerves project is really cool. It allows people to get started with IoT and fairly serious IoT development without knowing all that much about how to deal with hardware. So the Raspberry Pi is a very good starting point in any system, but I think Nerves takes that a fair bit further. So getting started with a Raspberry Pi is something I recommend to a lot of people in a few different circumstances. And it was actually how I got my real start with Elixir. The first library for Elixir, the first real serious piece of code I wrote for Elixir was for this device. You can see that this board is a sandwich of two boards. So this is the Raspberry Pi Zero, and this is an eInk display. It's called Inky, and I think it's Adafruit that produce it. No, Pimoroni. So the Inky P-Hat or FAT. And there's a larger variant called the WAT, which I don't have, but I should get one. The library supports it. Thankfully, other people, hello Jason, got one and tried it. So this is an eInk display that can do white, black, and red. We'll take a look at that. This is another example of a Raspberry Pi with another piece of hardware on it that I think we'll also have a moment to look at. I had this hardware lying around and I wanted to play around with Nerves. So I decided to port need to sleep. I decided to port the existing Python library from Adafruit to Elixir so I could use all the cool stuff. And I ended up doing that, and I got a lot of help from Emilio Niare with the sort of making sure I was making sensible Elixir code, and that was very helpful. He also helped me push the library sort of all the way there. So that was great fun and a good start to being involved in the community. Also, tons of support from sort of Nerves core team members throughout my learnings on different pieces of hardware I played around with. So I haven't updated the library for this one, and apparently it still works. So that's good. But what I have done now is put Nerves Livebook, which is a Nerves repository that Frank Hanleth is building out, which combines Livebook, which is a cool Elixir thing, with Nerves to give you sort of an easy start playing around with Nerves and hardware. So I've already flashed that onto this. I will show you the changes I've made to include my eInk work. Let's see, just the orientation. This is going to be the hardest part of this. Always orienting USB. So you should probably be able to see it start blinking. That means that it is starting. Meanwhile, we can, so this repository is I just cloned Frank's Nerves Livebook and followed the instructions for setting it up. And then I took the instructions for, I think it's going further is the section where if you need to customize, and I do need to customize a little bit because mix install does not work on top of Nerves Livebook yet. So I have this branch, Inky Chisel, and we can look at just what are the changes. I added 2 dependencies. And I added a font. That's important for Chisel. So this is a font. So that's what I added. That's already flashed onto this one. If we make any changes, we might have to reflash it, and that's not too much of a burden. So going in now, we can see that there are things on it. So I prepared a Livebook that we can look at. So this is Livebook. It's a live programming environment for Elixir. So I actually bothered to make this display blank for you guys because by default, it just shows whatever you did to it last. This comes with Inky library installed since I added it. And we can see here, we start the Inky library saying, we have a P-Hat, it's red. Please register it with the name Inky sample. And then this is sort of my default example, which is you set up a painter function that depending on what part it's working on, it will tell it to use different colors. Using this, you're essentially saying, please redraw the entirety of the screen using this function. So we can do that. This will tell us if the display is working as it should. So this is the default example from the docs. So let's evaluate. We can see that it's working on it. It's running. The Pi Zero is not a super fast machine. Oh, we have action. It's blinking. All right, so the refresh rate of an eInk display. So you can do some things to make it faster. You can use only black. You can run it in black and white mode. I think that's a little bit faster. The red takes a lot of time to sort of burn to completion. But yeah, what it does here is it paints 1/4 red, 1/4 black, 1/4 white, and 1/4 it will switch between black and red. So that looks kind of gray on this camera, I think. That's an eInk display. A neat thing about the eInk display is if I yank the power now, it will still show these squares, which is neat. I don't want to do it just to prove a point because it will take a little bit of time for it to come back up. Beyond this, let's see, what's his name? Luis Gabriel Roldan. I say it with flair, so it sounds like I know how to pronounce it. But he made a library called Chisel. Cool guy, had lots of fun talking to him around these things. He made a library called Chisel. Don't know what he's doing today. Haven't talked to him in a bit, but Chisel allows you to do text on these things. And those are my fingers, and that's my picture. Because he sent it to me so I could try it. And then I gave him a picture and he used it for the demo. So Chisel has this way of taking these bitmap fonts and turning them into pixels that you can then draw. So we'll tell it to load a font, which takes a little bit. As I said, the Pi Zero is not a very fast machine. That's something to be aware of. It's not deadly slow. It can do plenty of interesting things, but it's the lightweight of the Pi family. So now we loaded the font with Chisel. We define ourselves a put pixel function because that's how Chisel likes to work. I think there are a few other ways to do it as well. This was just what I got up front. So now we're doing 1 pixel at a time. So we are calling push with the option push skip, which means it will not attempt to redraw the display every single pixel, but rather it will defer the full render push, and then I will simply send no pixel at all and tell it to do a full synchronous push of the pixels. So this should mean that it will render some text in a black font offset by 4 pixels from the left and from the top. So let's evaluate that. Blinkety, 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 blink. It's re-rendering everything we had because it keeps that state around. It did turn up some text up in there. So that's the Chisel library. And if we wanted it to be bigger, we could either upscale it at the pixel level, or we pick a bigger font. This was just one of the ones I pulled from his examples. And here's my helper module for just making the screen blank for you guys before I show you things. Not very compelling if everything's already rendered to the screen. Can't just power cycle it, still show it. Now this is why eInk is the perfect thing to keep you going with a project, because it will keep staring you in the face with your latest misrendered failure until you're done and it's working. That's good and bad, but that's the case. So one thing I would like to do here is to add, that's why I have all these tabs open. I would like to add one of these other fonts, maybe take something larger. So there are a lot of fonts in this. Helvetica R12, I bet that's what that is. Let's try it. Adobe Helvetica. I don't think, maybe they licensed this. I don't know. So I'm just gonna play around with it. I don't pretend to have a licensed Helvetica, but I think we'll be okay. Hey, where did it save? Oh, I saved it to the right folder instantly. That's also fine. So I put it, this means I put it in, see, rootfs overlay fonts. So this will just be on the Nerves firmware when we burn it. And we do, let's do it step by step. So we do mix firmware. Oh, right. This, I need to tell it what kind of thing I'm firmwaring for. An RPi 0. And to upload, oh, I don't need to reburn it. That's just that part. So what it's doing now is that we are pushing a new firmware over SSH to this device, to this little thing. So that will put it on a second partition. Then it will reboot and attempt to boot off of that partition. And if everything is fine, it will bring it up with a new firmware, keeping the old firmware in reserve in case of serious issue. So we should be disconnected soon. Yeah, now we can see that this loading bar showed up. That means we're trying to connect the WebSocket, but we're having some trouble because the entire server just rebooted. Heck of a thing to call a server. This is my server. It's a nice little device though. I really like these for more sort of serious use. I do like the Pi 3 and the Pi 4 and all of that. They're all good fun to work with. I haven't tried any of the sort of serious production ones, so BeagleBone or anything. It might, yeah, now it redirected us back to nerves.local because it could connect, but the session we were on is dead. So we can still do this part. So now we will start the example where we repaint. While we're doing that, you can grab the name of this font. So it's HELV R12. So it repainted, and that stripped out the text for us as well, which is nice. Although the font is probably a more complex font, so it might even take longer. So now we loaded the font. Let's see if we can paint that one. See if it gives us a nice result. I think that's an improvement. More legible. So this is a way of drawing text on the screen. And we have actually built out drivers, so you could use eInk as well, which is this rendering library that typically renders using OpenGL. We did build a way to bridge that over into these eInk screens. So if you need to draw sort of squares and stuff, that might be helpful. I think that's most of it for the Inky. This is all it takes to do eInk stuff in Elixir or on Nerves. This is the amount of code for talking to the device. So this just starts a gen server, and then that gen server owns the connection to the screen. And if you want to do more advanced stuff, of course, you'd have to write more code on top of that. But yeah, that's essentially it. Frank and the team puts a lot of effort into making Nerves approachable. So I think it's a cool angle of getting at Elixir. With the way sort of Elixir is evented, so if you want to do some home automation or pull some data every so often and show it on something like this, if you parse your calendar feed, I know Jason Johnson, who helped them with this Inky library, I believe he shows his upcoming calendar events on his Inky, which just means it either gets updates from the calendar or it just pulls a calendar file and keeps an eye on it and knows the time and then updates whenever it feels it's appropriate. And that way you can show some information really easily. It doesn't have to do a lot of work to sort of relay that information to you. So it's not like it's it's working its little poor CPU off. It's mostly idle, and then it just shoves some information at you. Now, we have a second piece of hardware that we can look at. So let's unplug this one, and let's note that it is now unplugged and still showing hello world. It will continue to do so. This one, this is an OLED screen. This is the Adafruit OLED bonnet. And this was partially used for some nerves trainings. I think I had 2 of these, but I might have handed one of them on to someone else. It's a cool device. So these boards are really cheap. I don't think the bonnet is quite as cheap. I don't remember. It's usually the peripheral hardware that gets you with Raspberry Pi things. But yeah, this is an OLED screen, and it has 2 clicky buttons and a joystick, which is essentially 4 buttons. And I flashed this with the Nerf's Livebook stuff, sure, again. But also, we can just git show, we can check out my OLED branch. So I added chisel again. Not sure, I haven't used it on this one yet, but it's there. And I added an OLED library, which talks to the display. Yeah. And this one is cool. It's like a very small game console. So I prepped some here as well. It has, so this depends on some global config. So I set some of that up, and it creates a module from, this is a gratuitous use of behaviors. This is not necessary. But you start something that talks to the display. It talks over I2C. I just guessed that it was the first one. And then it complained that I hadn't set the address, so I added the address. And by default, this is the default example. Draw a rectangle and 2 lines. So it has this primitive drawing stuff built into this particular library, which is nice. And then I started looking at reading the button states, but I haven't actually done anything with that yet. So let's comment those out for now. So, but we run this, and now the screen is on and showing sort of an X. Ooh, I think the recording is getting that trippy flickering of the update frequency. For me, it's completely still. So the buttons are using GPIO with general purpose input output. And that's a very common way to talk to very simple electronics. Let's see if we can make something happen with these buttons. Actually, we can make a new section with this so we don't reinitialize the display every time we change it. Already started, that's fine. So, in a map 1. Oh, yeah. There we go. Now we have a bunch of references, but not in the way I want them. I want them to go, okay, ref equals, and then I want to return button and ref, and then map.new. So now we have these. We should be able to go, let's take a new section, and enum.map, button and ref. So we go through each button, and then we want to do circuits.gpio.read ref. And that gives us 1 1 1 1 1 1 1 0. I think we can do so it thinks up is 0. If I reevaluate it. All right. Now, let's press that button and reevaluate. That doesn't seem to change anything. Now, there could be a thing where I have pinned these incorrectly. Because I use this pinout.xyz. It's very useful. But one thing about GPIO pins on the Raspberry Pi, sometimes they use Broadcom numbers, the BCM numbers, or otherwise you might be using some other numbers. Don't really remember what the conversion was there. Yeah, so as you can see, I might have done that wrong. It's like GPIO 17. That's pin 11. All right, so let's try to fix that. Oh, I need these next to each other. Okay, 17, 27, 22. $17, $27. Ha! And that one I accidentally grabbed from the right number for. 23, 29, 31. 23. No, wait. 23, 5, and 6. Yeah, 23, 5, 6. So that would explain why the button might not have reacted the way I expected. Okay, now everything's a 1. So if I keep this button pressed and read again, A is 0. And if I press this one, oh, sorry, that one, that's A is 0. Now up is 0. Down is 0. Left is 0. Right is 0. Cool. So all of the buttons work. It might not be the coolest to only get the button press thing when we ask for it. So there is set interrupts. You can send a notification when the pin changes. And typically I would say, yeah, we can send a notification on all changes. So we want to use the set interrupts thing. Typically for this, at this stage, we're approaching what would benefit from having a gen server. And then we might as well just write one. So the thing is with these, when you want to react to messages sort of interactively, it's just easier to not do that necessarily in Livebook. You can do a lot with Livebook in that regard as well. So I move that there, but it's slightly more straightforward to do it in a real application. So we're gonna want to start my app.mydisplay.startLink. Just tell it to start my app, my display. And then we want to, yeah, we can just display.ex. That's what I'm gonna call it. But I'm gonna follow all the silly naming here because I don't want to bother sort of reworking that. Let's call it reactor. So this would be our thing that sets everything up and reacts to it. So we use a gen server. Start link. Quick and dirty wins the race. So yeah. We can do ops equal keyword put. So that should let us address it nicely and easily. Okay, so we still want to, so here we want to grab these. Just the pins. And we want to turn those into button refs, and that's suitable to do here. So, and for each of these, we also then want to set up these interrupts. So available options, suppress glitches. Oh, yeah, that's fine. We don't need to pass any of them. So I guess empty. And we want to make sure that these are successful, so we match on OK. And then we need to set up the state of this. So button refs. I think that's all the state we need to handle right now. And def handle info, and then I would expect okay, I think we need buttons as well because we're getting pin numbers here. So this says that the pin hits this value. Cool. So let's tell this to also be started. Right. In the application. No, not that application. Whoa, I'm deep, aren't I? Yeah, in this. And I will want to do some drawing based on the reactor, but let's start with just doing mix firmware and uploading new firmware. So I don't remember quite what I told the reactor to do. I did not tell it to draw that, so I don't think it has flashed yet. Because it shouldn't be drawing that if it has flashed a new firmware rebooted. Do I have reactor dot startlink? Yeah, okay, so it does exist. I'm surprised that it's still showing that, because I don't think I've added any of that. Well, let's see, ring logger dot attach. Actually, I should be able to start my own reactor. And suddenly, oh, maybe it didn't start the reactor properly. Don't know why it wouldn't, but this is cool. So now I can pretend that I'm playing a video game, and it puts things on the screen. Well, it puts things in my terminal. And okay, I haven't gotten any messages like that. I do wonder if it has some kind of issue with starting reactor. I don't know. I would have expected it to start. Anyway, but that's neat. We're getting the button presses. So now, obviously, what we could do, we could tell it to draw when we're getting these messages, which would be neat. So we can leave this. All right, hold on. There's a weird one for getting out of exit. All right, that also works. But there is a special command to quit an SSH session, even if everything has hung inside. And I know I had to use that when I was on a Mac in the olden days and dealing with these. Sometimes I needed to escape using that. So now, if we look at what we were doing in this, it should still be running the Livebook, unless I accidentally rebooted it just now. All right, not sure what I did to kill the Livebook. But I'm sure that's fine. Now, my app.mydisplay, it has all these neat features. Not that one, but this one. Oh, it can do fill directs. So we could draw a box for every button. We could also use chisel to draw text to it based on what button is pressed. But yeah, let's start with some rectangles. So what's the width of this thing? I think that's up here. Oh, it's in the config. There. 182, height 64. Yeah, let's not care about the height, but well. So button count equals length state dot enum count state dot buttons. So we can do, so each button we press can have 128 divided by button count. So item width equals width divided by button count. Now I'm worrying about what the offsets will be because I'm silly. I'll just do that to make sure we have a reliable ordering, because I don't think maps are ordered. And then position is what I want. So we take state.buttons and we push that through enum with index. Then we can do enum.find, I guess. I'll just enum find in a bit. Let's actually check what that will require of us. So we should be getting this fun thing. So we should be getting button and pin and an index. And so it will return this value, which if bpin equals pin, we should have, can ignore that. And we can just go, this is the position. And now we can, I think we have everything we need to draw a rectangle in the position I like it. So rect, yeah, this would be the offset. So we want the position times item width there. Want that to be 0. We want this to be item width, right? No, hold on. Oh, this is a bounding box. Right. Starting position. So that's start X probably. And we want that to go start X plus item width, and this will just go to the bottom. So we can do height -1. Can you undraw a rectangle? My next question. Or does it only draw what I send to it at that moment? well, this could be nil as well, I guess. If this is anything else, we do nothing about it. And when we press something, the value went to 0. So we want to check for the value 0. That's my thinking. So let's see what this gives us. I'm not sure. I haven't tried this. This is new. Okay, it's up. All right, let's see if pressing things will do anything. Not at the top, but we had that issue that maybe I failed at saving, but the reactor didn't seem to be starting on its own. So let's start it. Did it crash? I think it crashed. Shell process exited with reason. Answer call my app display wrecked and the process is not alive or there's no process currently associated with the given name. Okay. It's not just the reactor that didn't start. So let's start that one. Unknown driver. That's interesting and a little bit weird. Okay, let's see. So I think this was our config from before. Partially from memory. No, not just one line. All of it, please. The VS Code Vim mode is a piece of crap sometimes. Yeah, that's not what I wanted. Okay, it's pasting in this terminal is not behaving as I would have expected it to. That's unfortunate. Okay. Do I have to do it line by line or what's the issue here? Apparently, well, it's not that big a deal. We'll give this a bash and then wrap it up. So, okay, now that's started. And now we should be able to start the reactor without that causing a crash. Okay, it's not drawing. So, not sure if that code might go or just doesn't work. Actually, it's making the screen blank though. So, it did write something to it. So I might just be drawing that poorly. So I think that's where we wrap up for now. But I can recommend, especially the eInk display. I think that's for sort of doing your own projects. I think that's the most compelling one. It's very novel, very odd to work with compared to what you might be used to. And surprisingly useful. These are two very light libraries. So Chisel and Inky. That you can use to do a lot of damage. And if you want to sort of draw slightly more graphic-y things, you can do that with Scenic. And there's a driver to connect Scenic and Inky, which will work on Raspberry Pi 3 and back, but not Pi 4. So worth checking out. And if you just want to play around and get started with Nerves, the Nerves Livebook is super good because it allows you to figure all of this stuff out. And there's good tutorials involved and sort of resistors and blinky things. strongly recommend that. All right. Well, that's it for today. Thanks for watching.